Right, now that we have trained our models, we have our 4 models trained. We now want to see how they'll perform on never been seen before data or our test data. So here we're just setting up the predictions on the test data for logistic regression. It's just going to be a data frame, and here we are going to come up with the prediction itself. So that's what we're doing in that line, and here we're just now predicting. We are now using the model to predict on the X test, and we are going to get where it predicts the column. So it's going to predict 0 and 1, but we are only going to get the column, the 1 column. What is your prediction for it being fraud? What is the prediction for it being fraud? So the logistic regression get the probabilities, but we are only getting the probability of it being 1. And we are going to get that the log loss between the Y test and the predictions that we would have made. So the predictions of each record being 1. We do the same for the trees, for the random forest. We do the same random forest. We do the same for XGB, and we do the same for LightGB, and we print the results. So let's look at the results. If you look at the results here, you see that the XGB and the LightGB, they are way less than on the test set. They are way less than the logistic regression and the random forest, and that is no surprise. We didn't see any evidence of overfitting from those two. So yeah, it does make sense that definitely there will be much less than. They were performing very, very well. So based on this, XGB is doing well, but LightGB is not too far off. Now let's look at the other metrics that we're doing. Precision recall curve, average precision on the test set, though. On the test set, comparing it to our Y test, comparing to our predictions. You do the precision recall curve and also our area under the curve. So this is coming from logistic regression, 0.73, 0.98, like it was doing on the train set, right? So this is for the let me see. Yeah, predictions tested logistic regression. So this is for the logistic regression. These are the results using the test set, and we run the same thing for our random forest. Random forest is actually doing well, average precision, but that was the same. It was like, wasn't it 0.83? I think it was. So this is the random forest, and then our XGB is saying 0.87 for average precision on the test set, and AUROC is 0.97. Okay, cool. And then for LightGBM, 0.86 on the test set and 0.98 on the test set. So definitely, yeah, it's a contest between XGB and LightGBM on the test set. Even same with the training set. On the test set is going to be it's coming out to be the same here. So yeah, I would say personally, if I was to then choose a model, because we've done it on the test set, I would choose the LightGBM. If we're ending here, I'll choose the LightGBM because the LightGBM is giving good enough results, or results that are as good as the best model that we used, and it's much faster than the model that we had. So this is what you can do, and this is supervised learning, right? I'm just going to take supervised learning to a second step. We're still in supervised learning. We haven't figured out how to improve on this using unsupervised. There's a way to improve on this using supervised, like we have done now. It's called ensemble. Using ensemble is pretty much putting together different models to come up with a much better prediction. So maybe you predict using logistic regression, random forest and stuff like that, and then you predict overall. Let's see how that happens in the next